Today, dear colleagues, and participations of the conference, let me introduce topic of our research, um, intelligent information technology for multi-criteria vulnerability assessment of gas stations to the main types of accidents. Among the authors of this research, Arsirii, professor, head of information system department of the Odesa Polytechnic National University. Me, the reporter, senior lecturer of Information Systems Department, Sergey Smyk, associated professor, and two master's students, Vadim Oliinyk and Bieliaiev. So the aim of our research was to develop an intelligent information technology that will allow multi-criteria assessment of gas stations' vulnerability to the occurrence of the main types of accidents, and its implementation will allow a more rapid preliminary examination of the technogenic safety of gas stations and can be a methodological basis for other potentially hazardous facilities. The main objectives to be performed to achieve this aim is the development of the main steps of this intelligent IT, detailed development of some steps of proposed intelligent IT, in particular building a coding scheme for data about gas stations, obtaining weights of gas stations vulnerability criteria, building a generalized model for obtaining a numerical assessment of gas stations vulnerability, as well its interpretation based on fuzzy logic methods, and implementation of the proposed intelligent IT in the form of a decision support system and its approbation based on the data about the gas station network in the settlement. So in this slide, you can see the list of stages for building this intelligent IT, which we have done during the joint research project with University of Portsmouth, Great Britain, during the 2023 and 2024 years. So these 10 steps included identification of the main types of accidents, development of primary space of economic, environment, and social criteria of the gas station's vulnerability, obtaining vector of weights of these criteria based on an analytical hierarchy process, development of a secondary space of these criteria for assessing the gas station's vulnerability, obtaining estimates of values of the criteria of the secondary space for each gas station based on public data from the internet. Preliminary processing and coding the obtained data in secondary space, obtaining a vector of weights of the criteria based on HP in the secondary space, improving the general model for assessing the gas station's vulnerability considering previous stages, determination and interpretation of gas stations vulnerability assessment using fuzzy logic, building a knowledge base for assessing the gas station's vulnerability to main types of accidents. So here you can see the general scheme of building this intelligent IT for assessment of gas stations vulnerability. First, three stages were done in 2023 with our colleagues. We have built gas station vulnerability model, then prepared, formatted the primary space of criteria, prepared expert survey form, and collected database of expert evaluations, and then get the weights of the criteria in the primary space. It was done, and it's detailed described in the paper for conference in 2023. Next, taking into account group coefficients of economic, environment, and social criteria, we have formatted the secondary space of this criteria. Then, using this criteria, we collected data about gas stations network in some settlement from public information about gas stations using internet, public geographic information systems, and etc. Then this data were coded using a coding scheme. It's detailed described in the paper and can be get by link. So then this data helped us to estimate the station's vulnerability using generalized model. And then its numerical assessment of gas station's vulnerability is described and interpreted using fuzzy logic methods by trapezoidal membership functions and using some rules to build a database how to interpret gas station's vulnerability assessment. Detailed description of these steps to build this information technology is described in the paper for this conference. So here you can see the general model for assessing the gas station's vulnerability. It is the arithmetic mean of the vulnerability assessment for station for each type of accidents. In the study, we studied 3 types of main accidents to gas stations. The estimation is a multiplication of the weight of criteria E for G accident scenario, respectively, from the secondary space, and to the score E of criteria for F gas station for scale from 0 to 1, respectively, which was got from the coding scheme. And using this formula, we can get the general assessment of vulnerability of gas station. So about the results, here is the scheme form of the interpretation of assessment of gas station vulnerability, where this assessment belongs to 2 fuzzy variables at once, and you can see at the left side that it belongs, for example, to medium vulnerability and high vulnerability with the description what that means. Using rules of build knowledge base and using trapezoidal membership functions for low, high, and medium vulnerability. Based on the results of gas station vulnerability assessments, we plotted the distribution of assessment parameters depending on their location. In the figure, parameter x is the normalized value of the latitude, y the longitude, respectively, on which the gas station is located. Gas stations are located on the graph depending on the coordinates and have a color depending on the vulnerability assessment parameter to the main types of accidents. From this graph, gas stations can be divided into the following classes when comparing each other. Dark blue and light blue for objects there has the least vulnerability. Green, 3 objects vulnerability below average. Yellow, 3 objects medium vulnerability. Orange, above average vulnerability. Red and brown, high vulnerability. So considering the interpretation of gas stations vulnerability assessment, dividing it into categories using fuzzy variables, the results is shown on this figure. We plotted obtained values of 17 studied gas stations in the form of point values on the corresponding graphs of membership functions. As can be seen from the graph, one gas station has low vulnerability, 13 gas stations have medium vulnerability, 2 gas stations have medium and high vulnerability with different degrees, and one gas station has high vulnerability. This project was made possible through the UK-Ukraine Twinning Grant Scheme, funded by Research England with the support of universities UK International and UK Research and Innovation. To sum up, among the advantages of using the proposed intelligent IT, it should be noted the increased efficiency of preliminary analysis of gas station vulnerability. It also was noted that the proposed approach can be further developed and implemented in practice and can serve as a basis for assessing the vulnerability of more complex, potentially hazardous facilities. As disadvantages of the mentioned approach, partial non-universality should be noted, potential complexity of forming an initial model of the vulnerability of a technological object, and subjectivity in decision making while using multi-criteria decision analysis methods like analytical theory process and collecting experts' data. Also, due to limited implementation time and financial capabilities of the project, the group of criteria for slice was excluded from the consideration, and it's will be studied further. In general, this intelligent IT can serve as a basis for a preliminary review of existing gas stations and preliminary assessment of their vulnerability to the main types of accidents, which can serve as a basis for making decisions about extended assessment and limitation of the activity of closing the gas stations. So thank you for your attentions. Your questions, please.